Okay, so now for question 5, I ask you which alignment tool did a better job aligning the KISS genes. And the first alignment you ran was with Clustal. Now the second one will be muscle. So I have the Clustal run in one window, and I'm going to run the second one, the muscle one, and then I will share each screen individually, so then you can compare them. Let's do the tab. Okay, so to run muscle, you just Google muscle, and then, as my joke, you'd find a picture of my husband, but no. Oh, there's him. No, I'm kidding. So here, you go click on muscle, and you paste the same sequences as question 1, because this is the point of this exercise, to show you that even though we're comparing the same things, the alignment doesn't necessarily come out the same. Sometimes it does, sometimes it doesn't. If you remember, muscle is an iterative algorithm, so it will make one alignment, make a tree, give it a score, and then it's going to do another one and compare which score is higher. And whichever is higher, it keeps that one, does another one, and compares the third one with whichever is higher between the first and the second. It keeps doing that until the score no longer changes, in which case this is termed that the scores have converged, so it no longer then builds a new tree or a new alignment. All right, so all I did was I went to muscle, I went to EBI, as I told you, is the European version of NCBI. And then I look at the alignment, and it displays the way to interpret an alignment is the same way as in here you have some sequence, not necessarily the first one you entered, but maybe. And it doesn't end on that A, that zebrafish kiss 2 continues over here. And remember the indels, these lines here, the computer put them those so that it could fit in like these 2 arginines here. In the sequence of that gene, these hyphens here don't exist. So there's a proline there, and there's this aspartic acid there. They're right next to each other. That gap doesn't exist. The gap is introduced for the alignment purposes only. Okay, so that zebrafish, if I ask you what is the, I don't know, 10th, let's see, which one am I gonna ask you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if I ask you what's the 14th amino acid, then you go valine. And mostly I want to see, do you know to skip the gaps, because those gaps or indels, the hyphens, are not amino acids. All right, so this is what the alignment looks like when we used muscle. If you forget what you used, just scroll up. And I'm going to just let you appreciate how many things aligned. And what we're going for is how many stars or 2 dots or 1 dot did it produce in this alignment versus the other one. And generally speaking, we would say whichever produced more stars is a better alignment, because it found where the amino acids agree, and it had to introduce this indel, so see, like, to introduce this gap here, so that this arginine would like shift it up. It could have kept it there and then shift these ones down. Sometimes doesn't really make a difference, but what we're looking for is which alignment gave you more of these symbols on the bottom, which are kind of like, if you're ordering pizza, how much did they agree on the same ingredients? And that's just my analogy for how often or how conserved is that amino acid in that position. So the more stars or little symbols, the more they agreed. And the more just blank spaces, That just means that there was a lot of change in the amino acid in that position. All right, so this one has this many stars or symbols, and we could count them, but you could just have both alignments side by side. I wanted to do that, but I can only show you one tab at a time with the permissions I have set on this computer. So, okay, that's Clustal. Then I'm going to quickly switch or wait, sorry. This is muscle, and it also says right there. I'm going to switch to Clustal so that you see which one seems to have worked better. All right, so muscle. And then Clustal. So it says there, Clustal. Let me see. They actually performed very similarly. Let's see. I think in the beginning they agree. On the muscle, this methionine is over here. So there was like one more agreement over here. And let's see. In here on the muscle, there was something that agreed also. So in this case, one is not terribly better than the other. And maybe down here. Let's see. Maybe there isn't a clear winner in this case. So normally I'd say that muscle performs better, but this is a case where when you run the alignments, they're not the same as alignment. So they shifted the amino acids a little bit in relationship to each other, but there were some differences. There wasn't a clear winner. But in general, muscle performs